In the final days of May, Europe experienced one of the most extreme early season heat events in recent decades. Temperatures typically associated with the peak of summer appeared in spring, with records being broken across multiple countries at the same time. Behind this event lies a powerful atmospheric mechanism known as a heat dome. The term heat dome describes a weather pattern where a large area of high pressure becomes locked over a region, acting like an invisible lid in the atmosphere. This lid traps heat near the surface and blocks cooler air masses from moving in. To understand how it forms, we need to look higher in the atmosphere, around 500 hectopascals, which is roughly 5 to 6 kilometers above the ground. At this level, we can see the main structure of the weather systems. When a strong ridge builds up, the air begins to sink. As it descends, it compresses and warms even further. This leads to clear skies, strong sunshine, and continuous heating of the surface. The region affected by the ridge is shown as dark red on the map, which covers Central West Europe. At ground level, this corresponds to a strong high-pressure system where the weather becomes stagnant, winds weaken, and weather fronts are blocked. Heat is no longer released efficiently, so it accumulates day after day. The heat dome is closely linked to the behavior of the jet stream, a fast-moving ribbon of winds high in the atmosphere. When the jet stream weakens and starts forming large waves, it creates areas where weather systems become stuck. While the jet stream circulation is usually zonal, which means moving from west to east, during blocked weather systems, the jet stream is displaced further north and thus unable to penetrate into Europe as shown on the map. One of these waves can form a strong ridge over Europe, while low-pressure systems on either side lock it in place. This is known as a blocking pattern or an omega block. In this situation, very warm air masses from North Africa are transported into Europe, while the atmosphere prevents heat from escaping. As a result, a heat dome forms and can persist for days or even weeks. The outcome is record-breaking temperatures across many countries, with values that in several cases exceed previous historical extremes for the month of May. The table shows a list of countries and regions where the record temperatures were broken. What makes this heat wave remarkable is not only the intensity of the temperatures, but also its extent, duration, and simultaneous occurrence across much of Europe. The heat dome illustrates how powerful and persistent atmospheric patterns can become when the jet stream slows down and blocks normal weather circulation. And when these patterns persist, extreme temperatures can emerge even outside